Welcome back, guys. Today in this video, we're going to be talking about formalizing relations and functions. What are relations? What are functions? And we're also going to include some domain and range in here as well. So first of all, a relation. A relation is a set of ordered pairs. So just like right here, we have relation A as being these ordered pairs of 0, 0, 1, 1, 1, negative 1, 4, 2, and 4, negative 2. The reason it's called a relation is because we're going to look at what is the relation these ordered pairs have with each other. Now, when we look at domain, domain is known as the x values of these ordered pairs. So for this relation here, relation A, what is the domain? Or what are the x values? So when we look at it, we have 0, 1, 1, 4, and 4 as the x values. And so our domain for relation A would be 0, 1, and 4. Now, if you were listening a moment ago, I said 0, 1, 1. There were two positive ones in the x value, but we only wrote it once. The reason for that is because we don't repeat x values when we list them as the domain. Same with the 4s. There were two positive 4s. We only need to write it down one time. Now, our range here for this relation is going to be all of the y values. So when we plug in these x values, so like for example 0, what was the y value that went with 0? Well, right here, it was 0. And so one of our range values will be 0. Okay, but we look at all the y values and we put them in order from least to greatest, same as we did with the domain. So the y values from least to greatest, well, up here, just the y values, we had 0, 1, negative 1, 2, and negative 2. And least to greatest, when you put them in order, we have negative 2, negative 1, 0, 1, and 2. So again, the domain is just grabbing all the x values, okay, the first number in the ordered pairs, and grouping them together from least to greatest. And the y values are getting our y values up there and grouping them from least to greatest. So again, domain is the x values, range is our y values. Now for this next part, we're going to state the domain and the range of each relation. So we're given a table, okay? When given a table, can we find the domain and the range? So for this first table, what is our domain? Well, if you remember, we just said domain is going to be our x values. So we look in the table at our row for the x values, or our column here, and we have 1, 2, negative 4, 1, and 3. Well, 1 was repeated. So again, if you remember, we're not going to repeat the number when we list the domain. So we have negative 4, 1, 2, and 3 as our x values. Our range, or our y values, will all be listed here. And so we have 3, 4, 5, 6 as our range for this first table. For our second table, our domain is all of our x values here on the left. Again, we put them from least to greatest. Negative 3 is the smallest, then negative 1, and then 4, 5, and 6. Now our range. Okay, now we're going to look at the y values. From least to greatest, we have 1, 2, 6, 8, and 9. None of them were repeating, and so we write all of those numbers down. And for our last one, if we look at it, which one is going to be our range? Well, range is our y values. Okay, and what is it called when we have our x values? Okay, we're going to have our domain, right? So our domain here is going to be all of our possible x values, 2, 5, 3, negative 2, and 8. But again, we put them in order from least to greatest, and we have negative 2, 2, 3, 5, and 8 for our domain. For the range for this table, we take our y values, put them in order from least to greatest, and in this one, the 7s were repeating, and so we only wrote it one time down below for the range. Now moving on, those were relations we talked about, but now we're going to look at functions. So what is a function? A function is a relation, except that every x value has one and only one value of y assigned to it. That's the important part. Okay, a function is a relation, but the difference is you can only have one x value. You can't be repeating your x values, and every x value has to have a y value assigned with it. Now, one way you can remember this is this little statement here. You're not functioning properly if you get back with your x more than once. So It's not a function if you have an x more than once. Okay, they're your x for a reason. Leave them that way. So state whether the following relations could be a function. So here's our first table. It's a relation because it's a set of ordered pairs. So we need to know, is it a function? Are any of the x's repeating? We don't need to look at the y values, just the x's here. And so 4, -3, 6, -1, and 5. None of those were repeating, and so this would be a function. Let's look at the next table. Is this one a function? So is this relation a function? Well, we check out our x values. Are the x's repeating? We have 1, 2, -4, 1, and 3. The 1's repeated, and so this is not a function. For our last table here, we have a relation, a set of ordered pairs, and we want to know, is this a function? Well, we got to look at the x's, right? So 2, 5, 3, -2, and 8. Well, none of those were repeating, so that means this is a function, right? Ooh, no, it's not going to be a function because not every x value has a y value paired with it. And remember, every x has a y assigned to it. That was part of our definition. So this would actually not be a function. This would be rare to see though. Usually all you need to look for is, are the x's repeating and do they have different y values? That's what we're looking for to see if it is not a function. Now, what if we don't have a table? Maybe we have a graph and we want to know, is that graphed relation a function or not? So we can use the vertical line test. If a vertical line can be drawn so that it intersects a graph of an equation more than once, then the equation is not a function. So here's what I mean by that. Let's say we have this relation on our graph. Is this a function? So what we do is we draw a vertical line, or this is also called the pencil test. You can put a pencil vertically on your paper and slide it across from side to side and see, does it touch this graph more than once while it's vertical? Let's see, if I take this line and I slide it from left to right, does it touch that line, the graphed line here, more than once at the same time? And the answer would be no. It touched the line only once as it was moving across. It never touched the red line in two different places at the same time. So this would be a function. Now, if we look at this relation here, we draw our vertical line and do our vertical line test or our pencil test, and we slide it across. Well, looking at it, when we were at this point here, when the line got to this point, it was touching here as well as here at the same time. So it was touching the red line in two different positions at the same time, which means that no, this is not a function. It fails the vertical line test. So let's check it out with an equation. Y equals 2x minus 3. So here's a table of some of the data from this equation, and here's the graph representing it. So if I want to use the vertical line test, I get my vertical line, slide it across from left to right. It only touches the red graphed line once at a time, so it passes the vertical line test. And also, you can check it and look at the x's. Do they repeat? No, they are all different x values, and so this is a function. Now, here's a code word for you guys. Your code word is going to be function. Make sure to write it down. Make sure to write down the word function. That is one of your code words today. Now, moving on. Let's look at another equation. X equals y squared. Here's a table of some of the points, some of the ordered pairs from this. And here's the graph of that equation. So let's use the vertical line test and see if it passes or fails. We need to see, is it going to touch this blue line more than once at the same time? Let's see. Well, right here, when it touched this point, it was also touching this point here at the same moment, and so this fails the vertical line test. It is not a function. And if you look at our table, 1 and 1 in the x values, they repeated. This is not a function there, and also the 4 is repeated as well, showing it is not a function. So x equals y squared, not a function. Now here we have plotted points. We don't have a graphed line. So how do we do it with plotted points? Well, let's look at it. As we go from left to right, are any of these points vertically on top or below of each other? So let's look. This first one, There are no points above or below it, so that one's good. Here, same thing. And this is the same idea of using the vertical line test. None there, and none here, straight above or straight below. Another way you could check this is from the origin. This is -1, -2, -3, -4, -5, -6 for x. So when x equals -6, we have a coordinate. When x equals -4, we have a coordinate. When x equals 0, there's one coordinate. And when x equals, let's see, 1, 2, 3, 4, 5, 6, 7, 8. When x equals 8, there's only one coordinate. So none of the x's repeat. And so this would be a function. Now, our domain using just coordinates. Well, it's just the numbers I was saying out loud. The first one, the x value is at -6. The next one is at -4. The one in the middle is at x equals 0. And our last one over here is at x equals +8. Now what about the range? Domain was the x values. So again, our ranges are y values, right? So to find the range, we're going to find our y values real quick. So for the lowest one, we are at -1, 2, 3. So -3. The next one is at +1 for y. And these two are at the same y value. They're both at +4. So our range would be -3, 1, and 4. But again, don't forget, guys, just because the y's are the same does not tell us whether or not it's a function. To find out if it's a function, we only look at the domain. Okay, we only look at the x values. Did the x's repeat? Okay, let's look at another one. So right here, we have another set of points, another set of coordinates on our coordinate grid. Let's check our domain. So here it says we have -3, 3, and 8. Oh, so these are both x equals 8. X's are repeating, and so this is not a function. And our range, as given over here on the side, -3. So here we go, the y values, -1, 2, 3. Over here, they're both +1, 2, and +3. And we have them from least to greatest in both sets. All right. Now, what about a mapping diagram? Okay, so let's look at that real quick. A mapping diagram gives us, it's kind of like a table, but it's split up. And so here's our x values, here's our y values, or here's our domain, here's our range. Now the difference here is instead of writing the ordered pairs, they connect them with arrows or lines. So this is like saying 10, 15, 20, and then we follow the line. So 20, 45, 30, 25, and 40, 35. Those are our ordered pairs here. So this one is a function because each of the x values on the left only have one arrow coming off of them. So they are only being used one time each. So the x's are not repeating. It is a function. And here is your listed domain, which is these values here, and your range, these values here. Your x's and your y's. Same as a table, guys. Same as a table. Now, another code word for you guys. Next code word is going to be input. Next code word is going to be input. Okay, so let's look at one more mapping diagram before we leave today. So right here, it's a little bit different. Now looking at this one, this x value of 2 has 2 arrows coming off of it. So that x equals 2 is repeating. We cannot have x's repeating, so right away we can say this is not a function for this mapping diagram. The 4 and the 3 are only used once, but that 2 ruined it. It was being duplicated, so it's not a function. And here's our domain and range. X values is the domain, range is your y values. Another code word real quick, guys. Let's go with diagram. Code word, diagram. Okay, so make sure y'all had those code words for today so you get credit for watching this video. If you have any questions, let me know, and good luck.